I don't want a lot of the airtime be me going on to you guys for talking, so stop. All right. I don't know if you remember when we went through these in the regular school year, but they got to have the same base. As in the class that we're in integrated algebra 1, they got to have the same base. If they don't have the same base, that's right, you can't work them. Guys, you got to use logs, and it's really complicated, and there's a lot of other stuff that goes on. If I can't get 27 to the same base as I can get 9 to, okay, that is a very complicated math problem when you got to solve for an exponent, when you got to find out what exponent it is that you plug in to make an equation true. Now you can do it, and you use this thing called logarithms. We've not learned about logs yet, so none of ours are going to work out that way. What we've got to do is we've got to get them to the same base. Get to the same base. To get them to the same base, guys, you may have to think about the problems for a second and think about what some of the factors are. For example, I might have to figure out what you can multiply 27 by, what can multiply by itself by to give you 27 that you can also do to 9. Well, thankfully, that's one that we deal with a lot, and we know what is that number? 3. So what I'm going to do here to A is I'm going to change the number 27 to 3 to the third. Okay? So I'm going to change 27 to 3 to the third. So 27 becomes 3 to the third, and then this is x minus 1, because that's from the problem. That's 9. 3 squared, so I change that to 3 squared, and it's still got this x plus 2. Well, in this particular problem, that's where on the quiz stars we did all the stuff on exponents, because this is just rules for exponents. When you raise a power to a power, what do you do with the exponents? Okay, you add them if you multiply numbers with the same base. Because if you multiply numbers with the same base, you add the exponents. But if you raise a power to a power, like in this problem, you multiply the exponents. So in this problem, when I have 3 to the third raised to the x minus 1 power, what I want to do with those exponents is I just multiply them. So then I multiply 2 times x plus 2. Guys, and then to solve this problem, the steps are something that we did back in the first chapter. Look, let's solve this linear equation. 3 times x minus 3 x equals 7. Excuse me, guys. Okay, so x equals 7. Now, if you want to check it, as you can use your calculator real quick, so I would know 27. Look at this. Put in a 7 right there. So 27 to the 7 minus 1 is 27 to the 6th. So if I work 27 to the 6th power, if I've worked this thing right, I should get the same answer as 9 to the 7 plus 2 is 9 to the 9th. So if I've done it right, then I go 9 to the 9th. When I hit enter, it should be the same thing, and it is. Again, guys, I don't know what it is that keeps so much of the stuff we do this first semester, you can get right just by checking them. But some of y'all are afraid to check them because I think that you're worried that you'll go, oh no, I got the wrong answer, I don't know how to do it. Guys, you're going to know how to do it. You're going to know how to do these if you'll just slow down and think about them for a second and not get caught up with panicking about the problem. But, like I said, you got to think about it. Every once in a while, you got to go, okay, wow, how can I get, what can I do to some base to get the number 1/4 that I can also do to that base and get A? You don't know what that number would be? 2. Very good. Okay, so here in B, 1/4 to the x, I want to change to 2 to the negative second. What is 2 to the negative second? 1/4. 2 to the negative first is 1/2. 2 to the negative second is 1/4. So I go 2 to the negative second to the x. Again, guys, the reason I'm doing this is because I have to get them to the same base. In this problem, this time, that base that I'm going to get them to is 2. And so that gives me negative 2x. Then I'm solving, raise a power to a power, multiply the exponents. 3 times negative x minus 1 is negative 3x plus 3. Again, guys, I wouldn't... You need to have this information out there. You need to have the sheet out. Again, guys, solving this problem, you got to make sure you do your distributive property. That gives me that 3 right there. We're real bad about not getting that 3. Add the other side, x equals 3. Remember, letter C here. Got to have the same base. Again, 9 x plus 3 less than 9, 2x minus. I've got the same base. Since I've got the same base, it's nothing more than just dropping the base and setting the exponents up equal to each other. Be careful in this one. Be careful in this one. Subtract this over, you get x. Add that over, you get 8. Good. Is that a good final answer? No, not a good final answer. I want to go x is greater than 8. So remember, 8, comma, positive infinity. That right there says this 8 comma positive infinity is the same thing as x is greater than 8. I'm just trying to show you the different notation as well. All right. We'll roll down here a little bit. Work this D, E, and F. D, 100 and 1,000. Or excuse me, 10,000. I noticed a bunch of zeros there. So if I want to get them to the same base, I go 10. 10 squared to the x minus 3 is greater than 10 to the 4th x minus 7. 2x minus 3 greater than 4x minus 28. I'm sorry. Look, I just did it. Just did what I told you to be careful of. That should say 2x minus 6. Sorry. Two x. What is that? 22. X is less than 11. Give me a number that's less than 11. Try one of those. Try one of those real quick and see if it works. That's how you know you're getting them right. X is less than 11. So try 10. Throw 10 in real quick. Throw 0 in. 0 is less than 11, and 0 is easy to check. So if I throw a 0 in right here, I get 10,000. 3 minus 3. 0 minus 3 is negative 3, so that'd be 100 to the 10, 1 over 10,000. This would be 1 over a million. This would be 3 minus, or 0 minus 7 would be negative 7. I guess that would be 10 million. So it works. Guys, this is the right answer. It works. E. 4 to the x equals 32. Is there anything I can multiply 4 by to get 32? Yeah, 4 times 8. But remember, that's not what we're trying to do. We're not looking at ways to get 4. We're looking at the base. The base of 4 is 2. So 2 squared to the x equals 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 2 to the 5th. So 2x equals 5. X is 5 over 2. Or 2.5. 6, right here. 6 to the x minus 5. Problem on our midterm. Looks just like one of the ones that was on our midterm. 6 to the x equals 216. You got to do that first. You don't move the 5 over there first, it won't work out. So now I got to get 16. Guys, I do not have the factors of 16 memorized any more than you do. So I just got to sit here and think for a second. Let's see. 6 times 6 is 36. 36 times 6. Let's see, there's a 216. So 6 to the x equals 6 to the third. Now I have the same bases. What can I do with the bases? Just drop them. That's right. You guys, once you get them to the same base, just drop them. And x equals 3. Problem? Finally, you can check it. Check it using your calculator. Don't forget about plugging the numbers in. And if you panicked on the test, if you panicked on the final exam, always take that original problem, go get the answers and plug them back in, and just kind of work it out logically. I think the other day, a lot of the problems that you had to work, you could have logicked your way through a lot of.